morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So, in this video, we are going to discuss about the recurrence relations. So, what is the definition of recurrence relation is already discussed in the previous video. Then what are the methods to solve the recurrence relations is already discussed one method in the previous video. Now coming to this, in this video we are going to discuss about second method of recurrence relation and also third method of recurrence relation. What is a recurrence relation? Recurrence relation is a recursive function. It is a recursive function which contains base case and general case. Sometimes we are going to solve from the base case to general case, and sometimes we are going to solve from general case to base case. There are three methods to find the time complexity for the given recurrence relation. So, first method is a substitution method. First method is a substitution method. Second method is a recursion tree method. Recursion tree method, and the third one is a master's theorem. These are the three methods to find the time complexity of the recurrence relation. In the previous video, we already discussed about the substitution method. In this video, we are going to discuss about what is a recursion tree method. So, as the name implies, we need to solve the recurrence relation by constructing the tree structure. So, this recursion tree method follows divide and conquer strategy. In case of divide and conquer strategy, if the problem is big, we need to divide the problem into subproblems. So, again, divide the subproblems into subproblems until we get the solution is found, we need to follow the divide and conquer approach. So, in the case of n is divided into two subparts, one is n by 2, another one is n by 2. Again, n by 2 is divided into two parts, n by 4 and n by 4, n by 4 and n by 4. Like that, we need to divide. So, that will be constructed in the form of tree structure in case of recursion tree method. The main objective of recursion tree method is to find the time complexity of algorithm. The three methods, the objective is to find the time complexity of algorithm, but different methods can follow the different strategy. Whereas recursion tree methods follows the divide and conquer strategy. In divide and conquer, we have to divide the problem into subproblems until the solution is found. Consider one example how to find the time complexity using the recursion tree method. Solve the recurrence relation using recursion tree method. T of n equal to 2t n by 2 plus k. Here k is a constant and 2t of n by 2 is the recurrence relation. First consider the level 0. Level 0 contains t of n. T of n. That means t of 2 power 0. That means 2 power 0 means t of n. 2 power 0 is 1. That means we are going to get t of n at level 0. Next, again t of n is to be divided into two subproblems, t of n by 2 and t of n by 2. So that is k2 power 1, t of n by 2, n by 2. When we combine t of n by 2 and t of n by 2, we will get the main problem. Then, so coming to the t of n by 2, again divided into two subproblems, that is t of n by 4, t of n by 4. We will get to 2t n by 2, that is 2t n by 4, t of n by 2 only. T of n by 2 is divided into t of n by 4 and t of n by 4. That is t of n by 2 square. First term is t of n by 2 power 0. Second term is t of n by 2 power 1. The third term is t of n by 2 square. So, this can be further divided up to k level. In k level, so t of 0, 1, 2 and so on, t of n by 2. So, in the case of level 0, we are going to solve only one problem. So, in the case of level 1, 2 subproblems. In level 2, 4 subproblems. Level 3, 8 subproblems. Like that, we are going to solve the problems, or we are going to divide the problems into subproblems. So, how to calculate the height of the tree? So, n is equal to 2 power k. So, the value of k will be increased from 2 power 0, 2 power 1, 2 power 2, like that 2 power k. So we can write it as n equal to 2 power k. 2 power k is denoted as n. So we are going to take the log on both sides, then log n equal to log of 2 power k. So because log is taken on both sides, we are going to get log n equal to log 2 power k. So that is log a to the power of b is, we can write it as a b log a. Like that log 2 power k is written as k into log 2, k into log 2. What about k? Log n by log 2, log n by log 2. So instead of writing that log n by log 2, we can write it as k equal to log n base 2, log n base 2. We know the value of k, we know the value of k. Substitute those values for each and every level, that is coming to the step 3. Calculate the cost at each level. Cost at level 0 is k, that means two subproblems are merged. Whereas cost at level 1 is k plus k. Two subproblems are present at level 1. But level 0 contains only one problem, that is denoted as k. Whereas cost at level 1 contains two subproblems, k plus k, or you can written as 2 into k. That means the two subproblems are merged two times. Then we are going to go for the cost at level 0. That is 4 problems are there at level 2. K plus k plus k plus k, that is 4 into k. Two subproblems are merged 4 times. So we are going to calculate at the total level. Now we need to calculate the number of nodes at each level. Level 0, how many nodes are there? Only one node, that is 2 power 0. That is 2 power 0 equal to 1. Then what about level 1? Having 2 power 1, that is 2 nodes are present at level 1. That is denoted as 2 power 1. Level 2 contains 4 nodes, that is denoted as 2 power 2, that is 4. Next, level 3 have 8, 2 power 3 nodes. Like that we need to repeat for the last level having 2 power log n nodes, because it is a k level. K is, we already solved that, log n base 2. Log n base 2. So last level having the log n base 2. So substitute all these values from each and every level. We are going to get the total cost of all the levels. Total cost is cost of all the levels except last level plus cost of last level. Okay. Cost of each level plus cost of last level. Cost of level 0, level 1, level 2 and so on. Cost of last level plus cost of last level, cost of last level except last level plus cost of last level. Putting all these values into the formula, cost of all the levels means first level is k, second level is 2k, 4k, 8k, then and so on log n times. First for the last level log big O of 1 into n. Substitute all these values, we are going to get k into k, so take the k as common, 1 plus 2 plus 3 and so on log n times. That is equal to k plus log n into log n times. We are going to get the time complexity is T of n equal to big O of n. That is repeated for log n times plus n. We are going to get the time complexity is T of n equal to big O of n. That is the recursion tree method to find the time complexity of the given recurrence relation. So third method for solving the recurrence relations is a master's theorem. There are two variations are there in the master's theorem. The first variation depends upon the three cases. Second variation also depends upon the three cases. But in case of master's theorem, we need to concentrate on the three important terms. First one is what is the value of a, and b, what is the f of n value, what is the function of n, and what is a and b. So remember, a and b both are constant and it is a positive numbers, So a greater than or equal to 1, b greater than 1 are the constant, f of n is the positive function. Then the time complexity of the recurrence relation is given as T of n equal to at n by b plus f of n. A, b are the constant, f of n is a asymptotic function. That may be asymptotic function may be f of n equal to big O of n or big theta of n, or it is a big O of n, or it is a omega of n. That may be asymptotic function. What is n? N is the size of the problem. A means how many number of subproblems are divided. N by B means size of each subproblem. What is the cost of dividing the problem, and we have to combining the results. That is denoted by using the recurrence relation called T of n equal to AT n by B plus F of n. Let us discuss about case by case with the help of example for better understanding. So, basic conditions of Master's theorem is A is always greater than or equal to 1, B greater than 1 means A and B are positive integers. So, f of Sn is a polynomial function or it is a asymptotic function. So, the first one is f of n equal to theta of n power d. D is a power. We need to identify what is the value of A, what is the value of B, what is f of n. So, once we know the finding the value of A, B, f of n, then substitute those values and we have to compare A value with B power d, apply the appropriate case. So, what are the conditions? The first condition is find out what is the value of A, what is the value of B and compare A with B of D. Based on that, we need to apply the appropriate case in case of Master's theorem. There are three cases for the Master's theorem. Case 1, A less than B power D. Okay, if the condition is A less than B power D. So, we need to concentrate on A values and B power D values. What is the relation between A and B power D? So, whether it is a less than or equal or it is a greater than. So, depends upon the A and B power D values, we need to apply case 1, case 2, case 3. Coming to the case 1, so case 1 for A less than B power D. So, that is if it is A less than B power T, the time complexity T of n equal to theta of n to the power of D. It is the corresponding time complexity if A less than B power D. Consider the first example. T of n equal to 3t n by 2 plus n square. So, what is the given recurrence relation? T of n equal to at n by 2 at n by b plus f of n. We need to compare this recurrence relation with the given example and what is the value of A, what is the value of B, what is the value of f of n. T of n equal to 3t n by 2 plus n square. So, according to this, compare the equation. Then, what is the value of A? A is equal to 3, B equal to 2, then f of n equal to n square. If it is f of n equal to n square, then what is the power of 2? That is D. The power of n is 2, that is the value of D. Now, we need to compare A equal to 3, B power D is, B value is 2, D value is 2, 2 power 2, that is 4. That means A is less than B power D, 3 less than 4. So, condition true. Then, what is the time complexity? T of n equal to theta of n power D. That means D value is 2 square. So, T of n equal to theta of n square is the time complexity for the recurrence relation T of n equal to 3t n by 2 plus n square. Then consider the case 2. A equal to B power D. That means A value, B value both are same. Then same amount of work is done at each and every level. Then the time complexity T of n equal to theta of n power D log n. So, theta of n power D log n is the time complexity if A value, B value both are same. Consider the example T of n equal to 2t n by 2 plus n. Then compare this recurrence relation with the given Master's theorem T of n equal to at n by b plus f of n. Compare this Master's theorem with the given recurrence relation and find out the values of A, B and D. A is equal to 2, T of n equal to 2t n by 2 plus n. What is A? A is equal to 2, B equal to 2 according to this equation. Then D equal to 1. What is f of n? F of n is n. Then find out B power D. B is 2, D is 1. What is the power of n? Nothing is there means 1. 2n power is 1. 2 power 1. That is 2. What is A? A equal to B power D. Means A value 2, B power 2 also 2. A equal to 2. Then what is the time complexity? T of n equal to theta of n to the power of D. D means n to the power of 1. Log n is the time complexity for the given recurrence relation. T of n equal to 2tn by 2 plus n. Come to the third case 3. A greater than B power D. A greater than B power D. Case 1 is A less than B power D. Case 2 is A equal to B power D. Case 3 is A greater than B power D. Then consider the example. If it is A greater than B power D, the time complexity is so theta of n to the power of log A base B is the time complexity. N to the power of log A base B is the time complexity if A is greater than B power D. Consider the example T of n equal to 40 n by 2 plus n. You have to compare this equation with the given Master's theorem. So that is T of n equal to 80 n by B plus f of n. T of n equal to 40 n by 2 plus n. Compare this equation with the given Master's theorem. So according to this, A equal to 4, B equal to 2, f of n equal to n. What is the power of n? That is 1 only. That is considered as a D equal to 1. Now find out B power D. B is 2, 2 power 1 is 2. What is A? A is 4 greater than 2. Condition true. 4 greater than 2. Apply case 3. According to the case 3, so what is the time complexity? T of n equal to theta of n to the power of log A. Log A means log 4 base 2. That is theta of n to the power of log 2 square then 1. So log 2 base 2 is 1. That means theta of n square is the time complexity. Log 2 base 2 is so that is 1. That is n to the power of 2 is the time complexity for the given recurrence relation. So up to now what we have discussed, that is the method 2 to find the time complexity of the recurrence relation. So the method 2 is recursion tree method. In recursion tree method, we need to construct the tree structure by dividing the problem into subproblem. Each subproblems can be further divided until the solution is found. Okay. Then for that we have to go, we are constructing the recursion tree method. In recursion tree, we are going to calculate the cost and taking the sum of all the cost level, that gives the time complexity in case of recursion tree method. Then coming to the third method to find the time complexity, say Master's theorem. In case of Master's theorem, the recurrence relation is of the form T of n equal to 80 n by B plus f of n is the given form of recurrence relation. For this recurrence relation, there are 3 cases. Case 1 is A greater than B power D. Case 2 is A equal to B power D. Then case 3 is A less than B power D. So based on the A value and B power D values, we need to apply the different cases to find the time complexity of the given recurrence relation. Thank you.